Yes, we're here with period 7, our blue class. We've got Alonso sitting right in the middle. He's ready for today's lesson. Excellent, he's here. Let's get started. So, today's objective is to graph absolute value functions. That's the goal of today. All right, so let's look at what an absolute value function is. So you'll notice here, this is what we call the parent function. The parent function, if you've heard that before, have you guys heard that before? Parent function? No, you never heard that? Parent function is when it's your most basic function. So nothing has happened to it, you haven't moved it, you haven't flipped it, it hasn't changed at all. It's the most basic you can get for your function. So you'll notice we're going to have the absolute value of our variable x. Okay? And if you look at what it looks like, all right, you'll notice it's a v. You might be wondering, why are we doing this in this unit? The reason we're doing it in this unit is because if you cover up this half of the v, you have this line, which has a slope of 1. If you cover up the other half, what slope does that line have? -1. So when you connect them at the vertex point, it makes a v. All right, so that's our vertex point. Now, I'm going to show you today how we're going to move them around, how we're going to write them algebraically, and then ultimately you're going to spend almost half the class graphing, so practicing how to graph them. Okay? All right, so let's start with this one, the parent function. So I'm going to graph the parent function. Let's plug in some values into this function. Let's use these x values here that are on the x-axis. Let's start with 0. If I plug in 0, so do f of 0, what is the absolute value of 0? It's 0. So the ordered pair I'm plotting is 0, 0. Always, what is always? Like the numbers I plug in? Here we go. Let's plug in 1. All right, let's plug in 1. If I plug in 1, what is the absolute value of 1? Positive 1. So I'm graphing 1, 1. All right, if I plug in positive 2, what's the absolute value of positive 2? 2. So I'm graphing 2, 2. Excellent. I'm sorry? Let's do a negative after we finish all the positives, Camilla. So I have 3, 3, and 4, 4, and then 5, 5.
5, 5.
All right, so you can see that is part of our v. Now, Camilla wanted a negative. Let's do a -1. If I plug in -1, what is the absolute value of -1?
-1.
Positive 1. Right? Because the absolute value of anything is going to be positive. So I went to -1 in the x, and you told me it was positive 1.
-2.
So then I heard Josue say -2, comma, positive 2. -3, comma. You see where we're going here. We're creating our v.
Yeah, it is a v.
Should be a v. Okay, any questions on the parent function? That's what this is. The parent function. Yes, it can go many ways. I do know what you're talking about. Can you just pump the brakes? Okay, cool. It's just an expression. Yeah, Joe Budden, good song. Okay. You didn't even know that he was saying that, did you?
Yeah.
No, you didn't. The end of the movie, You Got Served.
No.
Man, I'm just serving you all over the place, Frank. All right, let's do number 1.
I'm ready.
Number 1. It says to move it 2 units down. Move it 2 units down. So I'm going to take this v. Somebody's already liked it. I'm going to take this v and move it 2 units down. Every point gets moved 2 units down. Now you might be wondering, Mr. Frederick, how are you doing that so fast? Well, yes, I do. But there's a way I'm going to show you later on in this class that's much more simple than this. Now, once you graph it, I want to make sure you know what it looks like if I were to actually give you the function. So do you remember how our parent function is f of x? I'm going to use g of x for this one that's 2 units down, because f and then g in the alphabet. Okay? Now, what way did we move for the purple one? We went 2 units down. So watch how it works here when you write it. It's the absolute value of x minus 2. Do you see where that minus 2 is happening? It's happening after the absolute value. So any number that's written after the absolute value, plus or minus after it, is going to be your up or down movement. That's your vertical movement. Anthony? It's a G, right? So Camilla's brain says, what if it had been 2 units up? Then this would be plus 2. Right, write smaller, Anthony. Any questions on the purple one? Okay, let's move to the next one. Now, I am going to go back to the original parent function, and move it 4 units to the left. So this vertex point right here is going to move 4 units to the left. All the other points are going to move 4 units to the left. Now, the key thing about all 3 of these V's, you should notice, is that they all should look exactly the same, but just in a different location. All right, I know the green one for me looks a little different, so I couldn't go all the way up, so I'd run into that purple function. But whenever you're moving a function horizontally and vertically, you're not going to change what it looks like, just where it is, right? So if I'm here, and you tell me to go 2 units up and 3 units left, so I go 2 up and then 3 left, right? I look the same, just in a different location. Okay? Everybody good so far? Let's write down the function that's in green. So I'm going to use the next letter after G, h of x. Okay, now here's where it gets tricky, so be careful. You ready? We said 4 units to the left. If I move 4 units to the left, in my brain I'm thinking that's negative 4. So watch how I write it when I write down this shift of 4 units left. Now, many students look at that like, wait, didn't you just tell me that you're shifting left 4 units, so it's negative 4? Why did I write positive 4? Why did I write plus 4? To wait for it, I'm going to explain why. Okay. Everybody good on green? Okay, now let's explain why. If you go to the next slide, you should see this formula. This is called the vertex form for an absolute value function. Okay? The reason it's called the vertex form is because the h and the k make the ordered pair that becomes your vertex. Okay? Now here's the interesting thing, and it's true for any formula you're using, whether it's in my class or another class. Do you see how the addition sign before k there? Right? Whenever there's an addition sign, it's going to act how you would expect. We went down 2 units, and down 2 units is minus 2. That's exactly what you would think. But look at the h. What does the h have in front of it? It has subtraction. That's where you have to think opposite for what you think is going to happen. Here's why. Okay, see if you can get it. We said we were moving 4 units to the left, and that's a negative 4, correct? So I'm plugging in to my h, negative 4. So when you plug in x minus your h value of negative 4, you're not going to leave it as minus a negative. You're going to rewrite this as a positive. So that's why it's always going to be the opposite sign when you're moving horizontally. So inside the absolute value, you got to think opposite. If you're moving to the right, this would end up looking with subtraction, x minus 4. Let's do another one so we can feel confident on this, okay? Let me show you how to do this one. Okay, let's use this color for f of x, okay? Now, before I even do anything, I ask myself, what is the vertex? What is the vertex? Remember, it's h and k. H and k. So what's my vertex point? I need numbers. So that's what most students say, 2 and then the negative 1, right? But I've told you every time, Alonzo, you're looking inside the absolute value, you've got to think opposite. So that h value is actually a negative 2. All right, so you want to think opposite. Now, what's the sign of the number that's outside? Subtraction. That's going to be always the same sign. You don't have to think opposite there. That one stays the same. Yes, Clarissa. So anything on the inside is a horizontal shift, right? This one is a negative 2, so it's going to be 2 to the left. On the outside is your vertical shift. It says minus 1, so it's 1 down. Now let's plot that point. Let's plot negative 2, negative 1. There it is. From here, I'm going to make my v by using slopes of 1 and negative 1s, right? Up 1, over 1 in both directions. Is everyone good on making the v? Any questions on making that absolute value function graph? Yes, Nita. I just stopped there. You can keep going. Okay, how's everyone doing? Everyone okay? Now we're going to make it really challenging. Okay, here we go. It says, to reflect this function we just created across the x-axis. Okay, so here's the x-axis. My vertex is right here. How far away is it from the x-axis? It's 1 unit. So to reflect it, it's going to be 1 unit on the other side. What about these points that are on the x-axis? What happens when you try to reflect those? If they're on the x-axis, they actually stay on the x-axis. All right, those points don't move. What about these points that are 1 unit above the x-axis? They're going to be 1 unit below the x-axis. And you should already see what's happening. What's happening to our v? It's going upside down. Here it is, my favorite questions, Carissa.
Maybe perhaps.
Maybe perhaps.
I like that terminology.
I think
Can I finish this and then I think your brain will see it, or you can ask it again. Okay. Now I want to make sure we're all good on the blue upside down V. Josue, are you still with me? Great, excellent. Everyone good on the blue upside down one? Now let's try to write it with the equation, with the whole function, with the vertex. So I'm going to use g of x. What is the vertex for this blue one? What is the ordered pair for this vertex and the blue one? It's negative 2, positive 1. So watch how I write it. Ready? X plus 2 plus 1. Let me see why I chose those. We said the x value was negative 2, so when I put it inside, I need to think opposite, and then the positive 1 is just exactly how it would be, plus 1. Now, we're almost done, but we're not done yet. It opens down, which is not how we did this one, right? Not how we did this one. This one opened up. So here's how you show it opens down. You put a negative in front. So anytime you see a negative that's in front of your absolute value, you know it needs to open down. Every time. Yes. Yes. Okay, Clarissa. Like this one here?
Yeah.
Okay. So this would be minus 2. Minus 2. Every time. Okay? Why is the y value 1? Because the ordered pair is negative 2, positive 1. So that's why this is plus 1. Leslie. Uh-huh. Always. Whenever you write your vertex, when you look at this number, the x value of your vertex, that should be the opposite when you write it inside the absolute value. Every time. Correct. And if it's positive, it becomes minus up here. But this one you should see is always the same. Right? That one's the same. Right? The y value doesn't change. Yes, let's go, Aviana. At this point? Okay, so do you remember the reflection across the x-axis? This is the x-axis. So if I take this vertex from this parent function, and how many units is it from the x-axis? It's 1. So I got to go 1 on the other side to reflect it. Yes, Clarissa.
What is how do you get negative 1 over 1?
Like talking about the slope that I did?
Yeah.
Right, so all of these that you do today will always have up 1, right 1, up 1, left 1, because we're making a V.
Oh.
Right? The only times when it wouldn't be like that, I'll show you what I mean. What if it had said, and we're not going to do any of these in this class. See this 2 here? That's going to make it a steeper V. Instead of like this that we've been doing, it'll make it steeper.
Oh,
Okay.
that's that game that we were playing.
What game were we playing? Were we playing again?
Yeah, the activity thing that you gave us the other
I'm not sure what we're talking about.
time. The thing you made us do.
The shaded.
Oh, the Desmos. Yeah, that's coming back. We'll do another Desmos at the end of next week. And it'll be something about this. Okay. All right? Okay, so here's what I want to do now. Alonzo, say what up.